Okay, so I'm going to Slack everyone a link to a website called REPL-IT. So if you look in the general channel, you will see a link which you can click on. And that will bring you to a website that looks like this. Do you get that website?
It's asking us to sign up or username and password.
You don't need a username or password? Is there a way to X out of that?
If you log into like Google or something like that, that puts you there. You just follow like Facebook online things.
Yeah, but you don't need a login. I haven't logged in once, and I've prepared a lot of curriculum through this already. You could log in. I'm not sure what benefits that gives you offhand. Cool. So this is what we're going to be using throughout the course to be able to read and write and execute code. And that's why I didn't ask you to download anything in advance, because this is a way that we can write Ruby code and see the results. So one really important thing to talk about is that we are going to be using the Ruby language to teach this course. However, this course really isn't about Ruby per se. It's about learning the fundamentals of coding. Everything that we're going to learn here applies to pretty much every programming language that I'm aware of. So these, the difference, the way I like to describe the differences between various programming languages is, this is maybe a little bit of an exaggeration, but it's like the difference between American English and British English. Like once you learn one, you pretty much know the other. They're a little farther apart than that example, but they're really close. Like a lot of the stuff we'll do in Ruby, like the exact same thing in, let's say, JavaScript. Except in JavaScript, every line ends with a semicolon, and in Ruby, we don't do that. But like, you could pretty much, learn one language from the other. And that's why, in fact, most of our graduates, even though we use specifically Ruby and JavaScript in teaching the bootcamp, most of them go on to other languages, to use other languages, simply because they can't. It might take them a few weeks on the job to learn a new language, but once you know one, you know the other. It is not like learning, let's say Chinese and Spanish, where learning one does not help you for the other, right? You have to totally start over again. But here, everything we learn here with Ruby will apply to 99% of other programming languages, certainly everyone that anyone I've ever come across myself. Risa, I think I overheard you saying you work with Python?
I do.
Okay,
I
yeah.
like Django.
Yeah, so.
I don't really like Django, but.
You don't?
I'm getting used to it. I like Python though, it's not.
But Python and Ruby, you'd say, is pretty similar, right? Yeah. So yeah, everything we learn here applies to all languages. So let's just jump right into it. I'm going to show some things here, and if you want to follow along, feel free. If you learn better by just watching and not following along, that's fine too. One thing that I'm going to do, although I might forget to do it in the future, is, again, this is not critical. It just avoids a little bit of confusion. Do you see this icon here called Add New File? I'm going to just click on it and click this green button that says Continue. And I'm not going to explain right now why I did that. I think we'll come across that soon, though. OK, so let's write our first line of Ruby code. Can you see this from here, or should I make it bigger? OK, so I wrote P space 50. And to run our code, we hit this play button. And the code runs on the right-hand side. So we write our code on the left-hand side, we hit the play button, and we see the result on the right-hand side. One of our students was a chemist before becoming a software engineer. And when interviewing, he explained to me, the reason I want to become a software engineer is because as a chemist, everything I try, I have to wait overnight to see the results. I just want a code where I could see the results instantaneously. So here we get to see the instantaneous results. P stands for print. And although most of us think of printing as printing out to like the printer that prints out like paper copies of whatever you're printing, in coding talk, print could mean printing information anywhere, not just on paper, but even here on the right-hand side. And instead of continuing to call this the right-hand side for the next 2 weeks, I'm going to call it what it's actually called. It's called a terminal. So we're writing our code on the left-hand side, and that's called the text editor. And the code is executed, and we can see the results in the terminal, which is on the right-hand side. So we just said to print out the number 50, and we can see that result right there. Any questions about that? It is super simple and super boring, but these are the building blocks for everything else you're going to be doing.
Does 50 mean anything?
No, it's just the number. It's just saying, I want to take the number 50 and display it, or print it, but meaning display it in the terminal. Yeah, for the same price, I could have said 49, and then we see 49. You could choose any number. Now we could also do a little arithmetic. Ruby and all programming languages allow you to do arithmetic. So we're going to say p1 plus 1 and run that. And we get the result of 2, which is perhaps not surprising. Let's do some other kind of mathematical expressions. And I'm about to say something really embarrassing in a few moments. So brace yourselves. So P9 minus 4 is 5. To do multiplication, you use the asterisk, which is the character above your 8 key. So 9 times 3 is 27. Does anyone know how to divide? Yeah, / divide. So if I did 9 /3, that means 9 divided by 3, where I get the result of 3. The embarrassing thing I referred to before is that this is all the math that I know. And I did take more advanced math in high school and stuff, but I forgot it all. And I guess the good thing about that is that that demonstrates that you don't need to know much math in order to code. Most people think that math and coding are equivalent, and they're not, because these are the 4 things in math I know: multiplication, subtraction, addition, and division, and that's all you need to know. Unless you're building like software that is for like a mathematical related type of application, but I've never done that, and most people don't in their careers. Okay, so now one thing that we're going to come across a lot is that programming languages are man-made, right? They're artificial, they're created by human beings. So the fact that this works sort of as we expected is in fact arbitrary. For example, there's another programming language out there called Clojure, and since what we have here is Ruby, it's not going to run properly here, but just to show you, to add 1 plus 1 in Clojure, you don't say 1 plus 1. Instead, you say this. You use parentheses, and you say plus 1, 1. That's how you say 1 plus 1. So whoever designed programming languages, they can design it however they want. It's up to them. It's purely artificial. So one of the reasons I like teaching Ruby as an intro language as opposed to Clojure is even though a lot of the concepts are interchangeable, it's just easier for most people to like catch on to Ruby, where you're used to thinking like 1 plus 1 and not plus 1, 1. And the good news is most languages use 1 plus 1. Python is 1 plus 1. Pretty much every other language I've encountered besides Clojure is 1 plus 1. But Clojure had to be different. So they're plus 1, 1. So this won't work. We're going to get an error. Basically saying, I don't know. Ruby says, I don't know what you're talking about.
Is this website, can you put it in any language and it will figure it out if you do it in the...
Yeah, so the way if you click on the home page here, you can choose from other languages.
Okay.
So here are some that you can choose from. Here's Clojure. Here we go. but I don't really know how to print in Clojure. So if I just do, I don't know what I'm doing. I might blow up the internet. 2. Yeah. Okay, I'm going back to Ruby now. So you could walk out of here saying, you learned Ruby and Clojure. So one of the first things we're going to really dig into is errors and getting error messages. Now, before we did P1 plus 1, and we got 2. However, as you saw, I used a lowercase p. The reason for that is because, again, languages are arbitrary, but the creators of Ruby decided that you need to use a lowercase p. That's just how it is. What happens if I decide to go ahead and use an uppercase p? Let's find out. So we get an error, and this is probably hard to see. Lisa, do you mind closing some of those other shades? Thank you. Can you see this when I highlight it? I'll read it to you. It says, undefined method, capital P for main object. Did you mean lowercase p? So again, this is basically telling us what went wrong. Saying you meant to perhaps say lowercase p, and instead you said uppercase p, but that's not a valid Ruby expression. Cool? Now, one of the biggest lessons that I think is worthwhile walking out of this class with is that error messages are your friend. And I will, I meant to grab it. We have a picture hanging up in the wall. Risa, do you mind grabbing it off the wall? It's a picture of someone, because we always stress in the bootcamp that error messages are your friend. So someone actually got an artist to depict that. It's like someone hugging an error message. And you'll see why in one of the upcoming exercises, you're going to feel that the error message is your friend. Let me break down for you one other piece here. Do you see? I'm going to keep this highlighted for now. So again, it says undefined method, capital P for main object. Did you mean lowercase p? Do you see this number 1 over here? That is one of your biggest friends, that number. That number is telling you which line of your code has an error in it. Now, as you can see, we're at line 1. We only have one line of code, but this is telling us that your error is in line 1. Thank you. So this is error messages are your friend. They really are. And when most people start coding, they're afraid of receiving error messages. They feel like they broke the internet, like I mentioned before. But that was a joke. You cannot break the internet. There's nothing wrong with trying things and getting error messages. That's fine. That's what programmers do every day. Most programmer perhaps spends more time battling through error messages than they do then creating new features. That's the way of it. So again, with one of the upcoming exercises, you will feel this tangibly. To demonstrate more of this line number thing, I'm going to put in a few lines here. So I have P1 plus 1, P3 minus 3, capital P 10 times 2, and P 1 times 1. So now when we run it, you'll see that it points out the number 3. Do you see that? This is super crucial. Number 3. It's saying you have a problem with line number 3. You want to look for that number. Again, the reason I'm stressing this is that most people, when they see an error message and they see that it's in a red font, they're like, oh, I don't want to look at that. I feel like I committed a sin or a crime or something. No, you want to look. It's your friend. You want to look at the error message. You want to see, hey, which line is wrong? Oh, it's number 3. What's wrong with number 3? Oh, this way you can easily fix it. So to really, really demonstrate this and hammer this home, I'm going to Slack to you a link that has an exercise in it. And I'll explain the exercise. So when you click on it, do you see this code in your browsers? Anyone? Does anyone see it?
Yes.
Yes.
If someone doesn't see it, then Risa can help you find it. So I Slacked it to you. In theory, you could type it in here, but it's easier on Slack. Does anyone need help pulling that up? Okay. Your exercise, so welcome to your first exercise, first of many. The first exercise is that when you run this code, when you hit the play button, you're going to see you're going to get an error message. Your goal is to fix this code so that you want to run it and not get any error messages. Now you'll see there's a few bugs in this file. So after you solve one error, you're going to get another error. And you have to battle your way through all the errors until you can run the entire file and not get any errors. Cool? So go ahead.
Give us errors.
Yeah, it says you completed the exercise.
Oh, really?
We're perfect.
You know what? I think I sent you,
It's a text answer sheet.
maybe. Let's see. What happens when I knock out the 1? Okay, take out the 1. Let me Slack. I apologize. I'll Slack you the new one, or you could just take out the 1. Yeah.
Yeah, just one quick question. Regarding how, I guess, it runs code one line at a time.
Yeah.
Once you encounter an error on a given line of code, for example, say we had an error on line 16 out of 3 lines of code, would that mean it would cease to run code for each subsequent?
We're going to talk about that. That's a good question, Shane. We'll get to that. So how many lines of code were there here?
1,000?
There's 1,000 lines of code. I think this is a good exercise for you to appreciate error messages. Could you imagine getting an error message that just said something went wrong? Now, this is what I always tell people who are thinking about, coding. People ask, like, how do I know coding is for me? And that's a long answer, and there's no one right answer to that. But I do tell people, like, you need to expect to pay a lot of attention to detail. Like, a lowercase p versus a capital P, that matters. And I always use this example. I say, hey, if you have 10,000 lines of code and you're like missing a comma somewhere, then none of it will run. Like, that's the level of attention to detail that you need. And people start like recoiling at that. I'm like, but when you are missing that comma, you will get an error message that tells you on which line you're missing that comma. So it's not like finding a needle in a haystack, but you do have to pay attention to detail. We once had a student who was not successful, and I usually don't say that because most people are successful, but he just refused to pay attention to detail. He's like, I don't care if it's a lowercase s or a capital S. I'm like, well, I don't care if you don't care, but Ruby cares. Like, it just won't work. Like, you need, yeah. So just getting attuned to that early is a good thing. And getting attuned to error messages is really important. So you don't shy away from them. They're your friend. Without these error messages, you would have never gotten through this exercise in a reasonable amount of time. Cool. Any questions? Were there any weird, I don't remember what bugs I snuck in here. Were there any really weird error messages in here?
There's an @ symbol for the function, which was why I asked the question.
Oh, I just threw an yeah. That's just wrong. Okay, cool. So let's move on to our first, I guess, fundamental concept. And this is a concept called variables. And you may have heard of variables when you took algebra, but this has nothing to do with that. So I stand by my word that all the math you need to know are those 4 basic arithmetic expressions of plus, minus, times, and division. This has nothing to do with algebra. So the best analogy, well, I debated it. So we have a dean of instruction. His name is Peter. And we spent a good 45 minutes debating what's the best analogy for a variable. This is what we like doing. We like debating these kinds of educational techniques. So we came up with like 10 different versions. And the one that we narrowed it down to 2, and I'm just going to go with one of them. A variable is like a nickname. Okay? So I'm going to start over. It's really annoying. Unless one of you could tell me how to start a new thing easily, what I do is I go back here, then click on Ruby, and then hit refresh. If someone finds a faster way to start a new code file, let me know. Okay. Once again, I'm going to click on that. Okay. Here I wrote Fred equals 1. What this means is that I am giving the number 1 a nickname. I'm calling him Fred. Yeah?
If you hit the settings
Yeah?
icon,
Yeah?
and then
Oh, and then hit new?
yeah.
Thank you. Thank you.
Nice.
That will save me from doing that the whole course. I appreciate it.
No problem.
Just hit the settings button again.
Okay, okay,
Yeah.
okay. So let's do that again. Fred equals 1. This is not algebra, where in algebra we'd be stating this would be stating a truth, that Fred is 1. That's not what we're doing. We're saying I'm giving 1 a nickname. I'm naming him Fred. Because wouldn't you want to name your number Fred? So that's what we're doing. We're giving him a nickname. We'll see. It'll become clear over time why on earth we'd want to give a number a nickname. The short answer, though, of why variables are useful is because we can use these nicknames to basically save this information for later. Think of it as like, here we go. I'm going to social security number. Now, I'm not putting my real one down here. And I'm giving that number 555555 the nickname of SSN. So this way I could store it for later and refer to it. And if I'm like, what was that? What was my social security number? Again, I don't remember, but I know I call it SSN. So I can just easily refer to that and be able to grab that number. Again, this will be clearer as we proceed. But again, think of a variable as a nickname.
Question.
Yeah.
In Ruby, it doesn't matter if it has to be an integer, float, or anything in that type of regard, or you can just use the variable however.
Yeah, good question. That's an advanced question. The short answer is you do not have to declare what kind of type of data it is. This will become clearer. If you didn't follow that conversation, that's fine. We'll get to this in a future time. Okay. Now, let's go back to Fred. Fred equals 1. We're giving the number 1 the nickname Fred. What happens if I now say P Fred? Well, what do you think might happen? So there's either 2 choices. It's either going to say Fred or it's going to say 1. And the answer is that it's going to say 1. The reason being is that we're using these nicknames in order to be able to grab that number that it's referring to. We don't really care about the nickname itself. We're only using the nicknames to remember the number that it's referring to. So when we say P Fred, it will say 1. Whenever we say a variable name, whenever we mention it, Ruby immediately replaces it with whatever number it's referring to. As soon as I say Fred, Ruby says, oh, you mean 1. If I say P Fred, it's as if I said P1. Because Ruby says, I know you don't care about Fred. You don't care about that name. The reason you gave want to name is to remember the number 1. When you say Fred, I'll give you 1. So P Fred is as if I said P1. That concept's a little tricky. So are there any questions about that? Yeah?
Will it function as a number if you have like Fred equals 1, Bob equals 2? If you put Fred by Bob, would it give you the number 2?
So we're going to see examples of like that shortly. If I think I know what you mean. If I don't know what you mean, then re-ask the question. Okay. Now, before we get to that, though, I'm going to say here, Fred equals 7, and then P Fred again. What do you think might happen? I can't hear? It's going to print 7. Well, first it's going to print 1, and then it's going to print 7. Yeah, so basically on line 1, we say, let's give 1 the nickname Fred. And then it prints it out. P Fred, which is 1, so it said P1, it prints it out, as you can see here. And then we say Fred equals 7. This is what's called overriding a variable. Basically it says, I know I named 1 Fred, but now I'm changing my mind. I want to name 7 Fred. So here on in, when I say Fred, I mean 7. Even though before Fred meant 1, now, henceforth, Fred means 7. So now when I say P Fred on line 4, it's as if I said P7. So you're able to override a variable in Ruby anyway. Some languages you cannot, but in Ruby you can. Any questions about that? Now why would you create a nickname for something and then change your mind? We're going to see this. This will become abundantly clear as we proceed. Any questions? Because this is the time to ask questions. Like, this is the fundamental stuff. If there's anything that I said that's not clear, let's make sure it's clear. Okay. Now, let's bring in 2 different nicknames here. So Fred, let's start Fred out with being 7. And now we're going to name 3 Tim. So now we have 2 variables at play here. I gave the number 7 the nickname Fred, and I gave the number 3 the nickname Tim. And I say P Fred, and I say P Tim. What do you think might happen when I run this code? Yeah, if I heard you correctly. So it prints 7, it prints 3. You can create as many variables as you want in a single file. So you could have thousands of variables going on. You're giving numbers nicknames right and left. Keep them as pets. Okay, now, let me blow your mind. What happens here? So I say Fred is 7, Tim is 3, and then I say P Fred plus Tim. What do you think might happen? 10. So it's good to know that people here know as much as math as I do. They can add. So again, we don't care about the nicknames themselves. Whenever we invoke the variable name, whenever we mention the variable name, we're just mentioning the nickname to get at the number that it's referring to. So when I say P Fred plus Tim, that is the exact equivalent of me saying P7 plus 3. And if I just said P7 plus 3, I would get 10. So here too, when I say P Fred plus Tim, it prints out 10 to the terminal. Does that make sense? Okay. It's not a simple concept. It seems simple, but it's not, because it's like you have to remember that whenever I'm referring to the nickname, I don't care about the nickname. I always care about the number that it's referring to. Even now as I'm talking, I'm like wondering, is nickname the best analogy? Oh yeah, that's what we came up with. If you understand what's going on, then I guess it worked. Okay. Now, let's do this. So we have Fred equals 7, Tim equals 3, and then we throw a monkey wrench here, and we say Gina is Fred plus Tim. So now what happens if I print Gina, what will I get? I still get 10. So you don't always have to directly make a nickname for a number. I could say Gina's a nickname for Fred plus Tim. Again, the reason that works is because when I say Gina equals Fred plus Tim, that's the equivalent of saying Gina equals 7 plus 3. So I'm assigning that result of Fred plus Tim and giving that result 10 the nickname Gina. So Gina is now a nickname for the number 10. Yeah?
I just want to make sure I understand. So Fred equals 7 is the variable?
Yeah, so there's 3 variables here. There's one called Fred, one called Tim, one called Gina. So in this line, Fred is the variable. Tim on this line is the variable, and then Gina, well, here I'm mentioning all 3 variables on one line. But the variable is the nickname.
Okay.
Does that answer your question?
Yes.
Okay. Any other questions? Okay, these are the real building blocks for all of coding. Okay, now this one might throw you for a loop, or it might not. Gina equals Tim plus Tim. What happens when I print Gina?
6.
That is true. Better be true, otherwise everything I know about coding is wrong. Okay, yes, it is 6. Why does that work? Because, I guess, could someone explain to me why does that happen?
So equivalent to 3.
Yeah, Tim is 3. So when I say Gina equals Tim plus Tim, that is the exact equivalent of me saying Gina equals 3 plus 3. There's nothing wrong with using Tim twice in the same line, because it's just a nickname for 3. If I call you by your nickname twice, I'm just referring to you twice. There's nothing wrong with that. I guess it could get annoying though. Okay. Now, what happens when I say Tina equals Jim plus Helen?
She gets an error.
That's right. I get an error. And what line is my error on?
3.
It's on line 3. And it says undefined local variable or method Helen. Saying, I don't know what Helen is. You never mentioned Helen before. You mentioned Fred, you mentioned Tim. You gave those are nicknames for various numbers. But I don't know, you never mentioned Helen. So this error message that starts out with undefined local variable or method whatever is one of the most common error messages you'll see. It basically means that your code references something that's never been mentioned before previously. So Ruby's like, I don't know what that is.
What makes the local variable?
That's an advanced question, so we're not going to cover it. It's a good question. We're not going to get into that now. And we'll see, as we encounter various error messages, some of them are more intuitive to understand, like, okay, I could get what that means. Some of them, we're going to encounter some error messages that they just don't even read like English, and I'll just explain to you what that means. Okay. Okay, what happens, I'm going to erase everything here. What happens if I say this? 4 equals Fred. I don't expect you to know this, but what do you guess would happen? I guess you're all running it and you're going to cheat, but okay, that's fine. You get an error message. And this one is actually one of those error messages that might be really hard to decipher. Syntax error, unexpected equals, expecting end of input, 4 equals Fred. That is frankly not very clear as to what the problem is. But I'll explain to you what the problem is. The problem is that whenever we create a variable, the rule created by arbitrary humans who made the Ruby language is that when you make a variable, the variable name always goes on the left-hand side of the equal sign, and the number, the value that you're assigning, that you're creating the nickname for, goes on the right-hand side. Here we've switched that, and that's illegal. We have not destroyed the internet or the world, or even Chicago, but we have committed an error. Variables are always, you have to start, the name goes on the left-hand side, it's Fred equals 4. 4 equals Fred is just not a thing. They could have made it a thing. The creators of Ruby could have said, oh, you could do it either way. But they didn't. They said you always have to, when creating a variable, you put the nickname on the left-hand side of the equal sign and the number on the right-hand side. Yeah?
Is that pretty much a universal facet of every coding language where you're trying to define variable?
That is, it's true in any coding language that I've seen, that it goes in that order, the variable on the left-hand side. Although, there's something tickling in the back of my brain that there's another language out there called Elixir that maybe you can go either way, but I'm not sure. It's definitely true for most mainstream programming languages. But it's arbitrary. They could have said it goes the other way, but they never did that. So we're stuck. And that's just a rule that you'll memorize, that it's Fred equals 4, not 4 equals Fred. And eventually you don't have to memorize these things. Eventually when you code enough, it's just built into your brain. Okay. I like to take a break like once every hour. Is now a good time for like a 10-minute break? Okay, let's take a 10-minute break, and then we will continue with the next section in a moment. Or in 10 minutes. Critical concept. So the next thing we're going to talk about is something called code flow, which is basically understanding how the computer actually reads our code. And that will be clear right now. Let's say I'm going to nickname the number 1 Fred. Not sure why Fred is my go-to here. But before that, I'm going to say pfred. So I have 2 lines of code. First line says pfred. Second line says I'm going to nickname the number 1 Fred. What will happen? What do you think might happen when I run this? You get an error. And let's read it carefully. What line is the error on? It's on line 1. And how do I know that? Because the error message explicitly says 1. And it says the problem here is that there's an undefined local variable or method Fred for main object, name, error, gobbledygook, yada, yada, yada. What is the problem here? What's wrong with my code?
You haven't defined the variable yet, so it doesn't know what to do.
That's right. So this is the key in understanding how the computer reads our code. The computer takes each line of code from top down and reads it and processes it 1 line at a time. As opposed to, what's the alternative? The alternative, you might think that the computer sort of looks at all the lines of code in advance and processes it all together as a big blob. That's not what it does. Instead, the computer just reads each line as its own set of instructions, top to bottom. So the computer starts at the top, and it says pfred, and it blows up with an error saying, I don't know what Fred is. Now, even though in the very next line, we say what Fred is, we say, oh no, I know what Fred, what do you mean you don't know what Fred is? On line 2, we say that we're giving 1 the nickname Fred. Basically, Fred is a nickname for 1. What do you mean you don't know what Fred is? The answer is that the computer never got to line 2. It just read line 1. It just reads 1 line at a time, top to bottom. And if it encounters an error at any point, it just stops there. Our computer never saw line 2. It never saw it. Now, as humans, we could sort of see the intention here. We could see, oh, this person who wrote this code probably wanted to print the number 1 to the terminal. But the computer is not smart. The computer is a dumb piece of metal that just takes instructions literally, and it just takes 1 line in at a time. And it says, pfred, I'm done. I've had it. I don't know what Fred is. I refuse to look at the next line. Any questions about that? So the program stops as soon as the computer encounters an error. It does not move on. Okay, and to demonstrate that, even further, just to hammer that home. What happens when I run this code? What will happen in the terminal? It will say 1, 2, 3, 4, 5.
Yeah, it should be fine.
What happens when right in the middle there I say p Fred?
Probably just write Fred, hold on, just put a number.
Error on 3.
I like this. This is a nice healthy debate here. Let's see what happens. This will really hammer it home. It prints out 1, 2, 3, and then blows up on line 4 because it says I don't know what Fred is. It does not go on to print 4 and 5. The computer quits. The computer exits as soon as it encounters an error. So, but it also, the fact that the computer processes one line at a time means that if there's an error up ahead, a few lines down, it doesn't blow up at the beginning because it doesn't know about that yet. It just reads one line at a time. So the computer starts out here. So really, it's really understanding how does the computer read this? The computer reads it like this. It starts on line 1, P1. Okay, I will fulfill that command. And it prints out 1 to the terminal. The computer executes and fulfills each line before it moves on to the next one. That's the key here. Then the computer goes on to P2, and it says, okay, I'll print that out to the terminal. And it does so. On line 3, it says P3. The computer says, okay, I'll process that, and I will execute it. I will do it right now. And I'll hit 3. And I'll print 3. Then it's P Fred, and the computer says, I'm done. I don't know what Fred is. I am shutting down. And that's it. So it never reads lines 5 and 6 where we tell it to print 4 and 5. Yeah?
Are there other languages that wouldn't do that? Like
Not that I'm aware. So the question is, are there other languages that might... Well, I guess let's think, what would the alternative be?
Well, I don't understand this, but I think like C is called a compiled language, so it takes everything, checks for syntax errors before it does anything.
Yeah, so in C, since it pre-compiles it, it wouldn't even run any of these lines because it says, hey, you have on line 4, I could see ahead, you already have Fred there, and I don't know what that is. I'm going to refuse to even run the first line. So yes, that is an alternative world. But in Ruby, Ruby's like super dumb. It's just like I'm going to read each. I'm going to fulfill like a robot each line one at a time. And if I get through the whole program, great. If I count an error, then I'm done at that point. So that's a good point.
For languages that do that?
Well, yeah. So it's compiled versus interpreted. So C is a compiled language. Ruby is an interpreted language. And there might be other languages and other models and paradigms out there that I'm not even aware of. But those are the two that I'm aware of. I saw another count. Yeah.
So how did the exercise skip around numbers?
That's a really good question. That's a great question. How did the exercise? I was hoping no one would ask me that. Okay. That's an advanced question. So there are certain kinds of errors that will cause the computer to, even Ruby, to not run any of the lines. And I don't even know if I know offhand why that is the case in some of the errors. So I think Ruby does go through a quick check for certain errors before it tries to run any of the lines. I think one of those errors that we had there was the @ sign. Yeah, so this basically contradicts everything I just said. Where Ruby said, I'm not running any of this because I see an @ sign up ahead and that doesn't make any sense. So I guess the answer here is that there are different kinds of errors. And this is like a real, I don't have an answer that I know for sure is true. But some errors are more severe where it won't run anything. But the most common error, but this is pretty rare that you'll encounter such an error. Most errors will run up until that point. That was a really good question. But in any case, the main thing I am trying to point out is that Ruby processes and executes each line top to bottom one at a time. It completes the line of code and fulfills it before it even moves on to the next line. Okay, so I have an exercise for you. And I think I'm sending you the right link and not the solution. But I guess you'll tell me. So I just put it on Slack. And I'll pull it up here. So your exercise is to fix this code, meaning get it to run without any errors. And I guess if you deleted the whole thing, that would work, but that's not what I'm looking for. I think what I mean is that move lines around, correct the order of the lines so that it runs. Recent. Just let me know when people are like. What?
Most of them have it. It's just too hot.
Let's put one more. Let's put one more. Okay, can someone walk me through this? What line do we have an error on?
9.
Line 9. Okay. It says undefined local variable or method orange. What does that mean?
Because we haven't told the computer what orange the variable, how much, what the amount of variable is orange stands for.
Well, we have. It's on line 10.
Right.
Right. So the order matters, right? Computer blows up on line 9 saying P orange. I've never heard of that before. It doesn't look ahead. It tries to execute that line as soon as it sees it, and it blows up at that point. So how do we fix that? Or what's one way to fix it?
Move 10 to...
Yeah, so we swap the order. So just give 5 the nickname of orange before we talk about it on the next line. Yeah. You see this green thing here? Just ignore it. That's why I was doing that thing before with this file thing, so those green things don't pop up. But when you do see them, just ignore them. We'll talk about them at some point. Okay. Yeah.
Why doesn't each line have to have a P to print? Because the ones that are like when you're defining a variable, they don't have to have P, like red equals.
Yeah, so good.
Put the P in front of it is the same thing.
Yes. Yeah, so what P does, so you're saying, why can't I just put that there?
Or why doesn't that happen?
Yeah, so what P means print. P is the keyword that says I want to take something and print it in the terminal. So if I eliminated, let's say, all this code and I just say red equals 1, blue equals 2, green equals 3, and I run it, we don't get those printed out because I never said P. P is the line that says actually have it show up in the terminal. All these lines do is just give 1, 2, and 3 nicknames, but I'm not doing anything with the nicknames until I use P. P says, okay, let's print whatever red is, in this case 1, let's print that to the terminal. Did that answer your question?
So it just prints the line before it, because when you just put print after before you had red, it just printed 3.
when,
Wait, before you use this example, you just did.
oh, because of here?
Yeah.
Yeah, so ignore all the green things.
Oh, okay.
Ignore the green thing. The green thing is confusing. That's why I'm trying to avoid it.
Does the green thing just indicate how many lines of code you just successfully ran, either printing out in the terminal?
Ignore the green thing. We will get to it. But for now, anytime you see green, just pretend it's not there. Don't try to read into it. So even though, yes, you see 3 here, that wasn't really printing to the terminal. That's just a green thing.
So it's nothing printed.
Nothing printed. Yeah. There's a green 3, that's nothing. That's nothing. Yeah, nothing printed. So if I want to actually print stuff, I have to use P. Whoops, not there. Greed. No, we don't want to print greed. Yeah. Now this is where it printed, because that's white. This is green, ignore it. Any other questions? Okay. I've got another exercise for you. I've got a whole battery of exercises for you. If you thought you'd come here just to listen to me, you're wrong. Here is the next exercise coming your way. I think. And this exercise, oh, this was nice of me. I actually put instructions. The code below causes an error when you run it. Your exercise is to fix it. Similar to before.
I know we're supposed to ignore the green, but when you get the green, that means you're fine.
Yes.
Okay, I'll just make sure.
Ignore it while silently knowing you succeeded.
I'm okay with that.
As long as you don't get an error message. I could have made this way harder as I'm looking at this. Next class.
But it is, we're just finding different ways to solve it. Like she solved it and I solved it. We did anything nice.
Oh, really?
Yeah.
Okay, when everyone's done, I'll have to hear how. Yeah, and deleting all the code is not solving it.
It's visually running through the business model, that makes sense. Is that
It's understanding.
yes, for example, function, you try to think how to do.
Yeah, it was like the running variable process, like the one and stuff like that, and
Yeah.
stuff, and I learned something all that.
Okay, who can walk me through this one? What line is causing the error?
10,
How do you know?
because that's called Q simul. So the line,
But how do you know? How do you know it's line 10?
I don't know.
Because the error, yeah, that's what I was looking for. Because the error message says 10.
Oh, okay.
So like, even if I did that and ran it and said, what error is the message on? What line is the error on? I meant to say. You'd say 10. Like, you don't have to see the code. You know it's on line 10. A lot of people think that like the instructors that are bootcamp are geniuses when they come and say, yeah, you're problem on line 10. Like, you didn't even look at my code yet. Well, yeah, we're just looking at the error message. It says 10. Okay, so what is the error on line 10?
Houston has not been introduced.
Yeah, it says I don't know what Houston is. So how do we fix it?
Split the line 10 and 11.
Yeah, this one was too similar. I should have made this one harder. Okay. Don't worry, I have some hard ones coming up. Yeah. Oh, that's a big number. Nothing printed here because you ignore the green. Any questions? Yes.
I did it, but you did it kind of fast, like you just switched it without typing it in.
Oh, so I just selected this and did Command X, or in Windows it's Control X, and I cut it, and I went up here, and I hit Enter, and I did Command V, or in Windows Control V, and that just pastes it in, and I just switched the order like that.
Line 13,
Line 13, yeah.
the two
Ha! I was waiting for someone to ask that. I set you up for that. You want to know what are those two asterisks? Yeah, great question. So the two asterisks mean exponent, so like 2 to the 4th. So I guess I lied when I said you only need to know multiplication, subtraction, addition, division. You can also know, you don't have to know exponents, but that is what that is. Other question.
So I think I like followed the pattern and also like skirted the rules a little.
Yeah.
Instead of like switching around the code,
Yeah.
I made Jefferson, I added a line and made Houston equal 4, and I got the same answer.
So you just
I gave Houston a value up, like a numeric
up here.
value underneath Jefferson.
Yeah, that works too. Comes maybe a different result from what the original coder intended, but I didn't ask you to figure that out. I just asked you to fix it. So yeah, that works too. Yeah. I had a feeling you'd ask that next. The percent sign is getting the remainder of a division operation. So I'm just going to type this in here. 10 divided by 4 is what? That's weird, right? It's 2 remainder 2. So when we say 10 divided by 4, it actually doesn't give us the remainder, it just gives us the 2. I realize this is a terrible example. Hold on. Let's do 11 divided by 4. 11 divided by 4 is 2 remainder 3, right? So when I say 11 divided by 4, it just says the 2, it just lops off the remainder. It just doesn't give it to you. Mm-hmm. If I do 11% sign 4, then I'm only asking for the remainder. If you ever want to know why you'd ever use that for real, we might encounter that. Actually, we'll encounter that on a different day. So that's my way of sneaking in some new concepts there. But any other questions?
Why would somebody want to do that? Why can't they just do 3?
Do what?
Why can't they just do 3?
3 where?
If they want the number.
Oh, if you want number 3? Yeah, you're right. No one would want to do that just to get 3. But if I had 2 variables and I don't know what numbers they refer to, and I want the result, then I could divide those 2 variables. This will become clear in future.
Okay.
Yeah, good question. Yep, you're right. No coder would ever type in like 11 divided by 4 in their code, because they could just type in the result instead. Yeah, yes. You'll see where this comes up. Good question. And we have another exercise. So if I didn't give you all these exercises, my throat would become dry. So here's another one coming your way on Slack. Okay, let me explain this exercise. Okay, this exercise, this actually involves something that's called a comment. I've actually had it before in one of the exercises. When you use a pound sign in Ruby, anything that comes after that is not considered code. You can just write whatever you want. You could write English, and basically Ruby ignores it. And the reason people write comments is for things like this, where I want to give you some extra information in the code, but I don't want to cause an error, so I just do a pound sign, and everything after I can write whatever I want. I can write plain English. So let's walk through this. At the beginning, when I say red equals 3, that means I'm giving 3 the nickname red. And to keep track, the exercise here is to keep track of the variables and what numbers they refer to as we proceed through the code on each line. So as of line 3, when we say red equals 3, so red is 3, because we just said so. Green doesn't exist and blue doesn't exist. Then we move on to line 4, where we say blue equals 8. So now red is 3, green doesn't exist, but blue is 8. Now I say green equals red plus blue. So red is 3, green is 11, and blue is 8. Your exercise is to complete the rest of the comments here and keep track of what red, green, and blue are at all times on each line. And this time, when you're done, go ahead and save it, and then you can Slack it to me, and I'll look at it at some future time. So to Slack me, you don't have to Slack the general channel, but you can find my name, Jay, in the direct messages on Slack, and just Slack me your results. So when you save this, a new URL will come up here. Just copy that and paste it into Slack and send it to me. And if you need help with that, Risa and I are here. Okay, well, let's walk through this one line at a time, like the computer. So on line 6, what is red? 19. What's green?
11.
And blue? Okay. How would we test this out to know if we're right? Yeah. Awesome. So let's do, I'm going to do P red, P blue, P green right here.
Right afterward.
Right afterwards. Yeah. So right after line 6. And I'm going to run it and ignore this error. But it says 19, 8, 11, which is what we said. Oh, it's confusing because I did it out of order. But yeah, that confirms that we got that right. Cool. Okay. What happens on line 7? Green is 0. What's red?
Doesn't exist.
No. Red doesn't exist? Why does it not exist?
I just want to
So red exists, it's just not mentioned on this line. And that's what I meant before when not exists. We haven't defined it yet, but it's still around. Sorry if that wasn't clear. And what's blue? Blue's still 8. Okay, well, let's confirm if we're right over here. We're checking red, blue, and green. And we got 19, 8, and 0. Okay, that's good. Okay, and this is where things get tricky. What happens on line 8?
Error.
We get an error because we say red equals blue divided by green, which is the equivalent of saying red, we're giving a nickname to 8 divided by 0. Now, forget again, I don't know math, but for some reason in math, you're not allowed to divide anything by 0. And if you're a mathematician, you can explain it to the rest of us. But I don't even, as a programmer, I don't even need to know why. Just, it's a rule. You cannot divide something by 0. Probably because it doesn't make sense. And we get an error. It says on line 13, divided by 0, 0 division error. So if you've never heard of this error before, you're like, what on earth is that? But now that you've heard of it, that's the error. When you try to divide something by 0, you get an error. And the program stops. So we're done with the exercise because nothing really changes. These lines don't even get run by the computer. Now, if we could, for the fun of it, eliminate that line and try to see what would happen with the rest, but I'm not going to. But don't feel bad if you did. The main point of the exercise was to track the variables. If you didn't know about the 0 division error, that's fine. That's why we're introducing it now. Yeah?
Why did it say your error was on line 13?
Just because he added some extra lines in there, like print stuff.
Yeah, if I run it again, it's on line 8. I had put in the P's before, so it was... Yeah.
But with having this error, doesn't it affect line 9 because red basically is an error at that point?
Well, the computer doesn't even see line 9. These lines never get seen by the computer because it shut down beforehand. The computer is a quitter. Just stops when it gets an error. Doesn't try to go that last mile. Okay. Could you believe it? I have another exercise for you. Just so you know, I have 3 more exercises for you. And then we'll take a break. Okay, this is a different kind of exercise. Here, do not run the code. The idea here is that you're going to predict. Try to predict what will happen when you run it. I guess after you've predicted, you can test it out to see if it's... But don't do that too quickly. Make sure you feel like you know what it's going to do. So I just slacked it to you on the general channel. And I will put it up here as well. It's not about math. It's not coding, but we are using some math here because we've only encountered numbers so far. You can use your calculator to help you out with this.
We can leave notes on the current exercises.
You can do whatever you want. Yeah.
Not seeing the latest latest one.
What's that?
Not seeing the latest.
Oh, no?
758 is the one I see.
Go back to the general channel.
Oh, there we go. Okay.
You see it now?
Oh, I see. Because I'm seeing
There's no intended defamation here against any particular social network. It's just an exercise.
It's just like, fuck this, it fails. That makes sense.
It's hard to know because people are just predicting.
There's some people who are still working on it,
Yeah.
on the other side of things.
Most of them.
Okay, so I guess you could run it and see what happened, but what happens when we run this code? Yeah.
We have a zero division error on line 11.
Okay, and is that it?
I mean, yeah, that's
Yeah,
what I
yeah.
anticipated. I don't know.
Yeah, it wasn't a trick question.
Okay.
But
Oh.
we get a zero division error on line 11. And again, lines 13, 14, and 15 do not happen because the computer shuts down on line 11. It's done. Is that clear? Okay. Two more. I promise. I think. Here we have another prediction. These are clairvoyance exercises. Coming your way in the general channel. Predict what's going to happen. I was running out of caffeine when I made this exercise. So predict what everything the program will do. Everything Ruby will do with this. Huh? People have their predictions. Do people need more time? Do some people need more time? I'm not in a rush. Okay, let's hear some. Well, I guess it's easy to know if you're right, but yeah, let's hear some predictions. Yeah. Yeah, so we're going to get an error on there, but what else happens before that even?
Should print 98, 24, 99.
So we're going to predict, well, I guess let's just see it. This is tricky. So, well, we'll see. Yeah, so as Crystal said, we do get that undefined error on line 13. But before it gets there, the computer does successfully print out 3 numbers to the terminal, being 98, 178, and 99. Now there's some, did anyone, I'm not trying to call you out, did anyone like not predict that? So it's not as tricky as I thought? Okay, let me point out what I thought might have been tricky and try not to confuse you. When we say p what minus 3, right? So what is 101, minus 3 is 98. When we get here, what is what? It's still 101. That's what I want to point out. Even though we did print out whatever what minus 3 is, we never said anywhere that we're changing what. So when we say print go plus what, we are printing out 77 plus 101, which gives us 178. And then we print yeah, because why not? And then we print hold the door, which gives us an error, because there's no such thing as hold the door. What kind of thing is hold the door? It was never defined.
So if we were changing it, then the next line after 7 would be P equals 98. And then go into 9.
Sorry, which line?
After 7.
Here?
Yeah.
If you wanted to do what?
If we were changing it.
Oh.
Is that where we would change it?
If you wanted to change what?
Yeah.
You could, we'll get to that.
Oh.
We'll get to that. Yeah, good question. A lot of advanced questions tonight. Okay. One more. Any questions about this before I move on? Were you able to predict this? This is good. This is good. Okay.
It could also be 1 to 12.
Okay. We have one more prediction exercise. And this is the first code snippet that we'll have encountered tonight that actually resembles real code instead of this randomness. So I slacked it to you in the general channel. I'm putting it up here.
Just a prediction.
Yeah, just a prediction. But also take time to try to think about what this code actually is trying to do in real life. And you can use your calculators. That's what I would do. Okay, let's hear some predictions.
1375.
Okay, 1375. Could someone explain to me what they think this code is like doing in real life?
Calculating the price of like your total amount, like at the grocery store, you know, how many different things you bought.
So what is this? What do lines 1 through 3 represent?
Well, items.
The price of milk, the price of a banana, the price of a protein bar. And this is the convenience store, because the regular grocery store, they're much cheaper. What do lines 5 through 7 represent? Yeah. And I guess tax is sort of self-explanatory, everyone's favorite topic.
The tax is written wrong.
Is it written wrong?
Yeah, it's 110%. Shouldn't it be 0.1 or 10%?
Oh, I just made up a tax rate. Is that what you mean?
Yeah, like I would have written 0.1.
No, but isn't.
Oh, I see what you mean. Because the way I'm multiplying it on line 13, I would do the 1 point. Yeah, you're right. Good point. In a vacuum, I would say 0.1. But the way I'm using the calculation on 13, I had to put the 1 in so it calculates right. Okay, what's going on line 11?
It's giving you the equation to figure out how much each product is worth based on how much you bought.
Yeah, so it's basically, this gives me like how much I'm paying for milk. This is how much I'm paying for that one banana. And this is for what I'm paying for my 2 protein bars. And all that becomes my subtotal. And then I calculate tax. and then I print out the total. So this is, again, this is the first example we've seen tonight of where like this actually might resemble some real world code. And before all variables were meaningless. Here actually variables are used to represent real life concepts. So we're sort of breaking into that. Although we'll revert back to ridiculousness shortly, don't worry. Okay, so is anyone, what's that?
Wouldn't it be safer to do it the way she's suggesting, actually?
Yeah, I rewrote the bottom one.
Okay, we
So
can,
it makes sense that you have to do that.
yeah. Let's come.
I said then you have to change the last.
So you did this.
Um,
Whoops, not that. That. And then what did you do down here?
I did the subtotal times tax in parentheses plus subtotal.
Okay.
So
Yeah,
it's the same
yeah,
thing.
yeah. I just did it a different, weird way. Yeah.
I was just thinking it'd be easier
To understand.
If you modified the code.
Yeah.
Like you get a new tax rate or something.
Yeah.
Yeah, we still substitute.
Yeah. That's fair. So let me.
Right.
Yeah, let's do that. I agree with all your suggestions. So let me change that.
And then parentheses,
So your tax is a
subtotal.
percentage?
Subtotal plus
Parentheses.
whatever that is.
Right.
Okay.
So is your tax a percentage or an addition?
This represents 10%. 10% tax.
So then we're
I
gonna
didn't
change
get,
the
I
tax
thought
rate.
you were trying to say the tax was $1.10.
No. So that's why, that's like Michael and Sam are saying it was unclear. My code
Okay.
was written in an unclear way. It still worked, but this is, we can make a solid case this is clearer. So it represents the 10% tax rate, which isn't real life, but what's the real tax rate? 9%? I don't know.
Yeah.
It's not far off. What is it? More than that? Okay, yeah. We need new elected officials. Okay, so what is the result?
1375.0002.
Oh, but look, in this way it actually works out really nice. In the other way, okay, this opens up a whole new can of worms. Okay, this, if you did it this way, your prediction may have come out correct that the result, your total cost of that grocery trip is $13.75. But had we gone the other way, and this really is not the point that I want to talk about, but it's interesting. So this, in theory, should be the same. This should also come out. If you try this on your calculator, it should also be $13.75. However, it ends up being $13.79 and a little bit of a scraping off a penny. Good luck getting change for that. Why on earth? Again, if I tried on my calculator, let me pull out my calculator. 9. Why does my calculator start at 9? Calculator, tell me what. So what is this? What's the subtotal? 1250. So 1250 times 110, right? That's what, right? Subtotal is 1250
Yep.
times 110 is 1375. So why does Ruby tell me that it's that crazy number? And the answer to that is that there's some weird thing in computer land called floating point arithmetic, which I don't have to know and you don't have to know, but it's something weird that computers do, and it's something to look out for, and it can bite you like that sometimes. And that's all I'm going to say on the topic. So yes, computers sometimes do weird things. Now why it did it weird in this way and not the other way has to do with understanding floating point arithmetic, which I don't understand and you don't understand, and that's fine. But the way, usually when I'm dealing with floating point arithmetic comes up whenever you're dealing with decimal points. And what I end up doing whenever I deal with decimal points in my code is I always do something to round it. So if I was doing this math, I would just say, take whatever that result is and round it to like 2 places to the right of the decimal point.
What's the command for that?
I'm not showing you now purposely, because it involves new concepts, which we're going to get to, but I don't want to jump ahead.
Roger.
Yeah. Any questions about this or about anything before we take a break? Actually, that's a terrible way to elicit questions, is to say, any questions before we take a break? I guess I'll ask questions after we come back from the break. So it's 8:25. We're going to meet up at 8:35 and then do the last segment for tonight. Okay. We now are going to set things up one notch with variables and try to address one of its trickier parts. But hopefully we'll make it clear. On the screen I have 3 lines of code. Jesse equals 1, Jesse equals 2, P Jesse. What will happen when I run this code?
2.
What about 2?
It will just, it'll just print 2.
It'll print 2 in the terminal.
Yeah.
Cool. Why? And ignore the green thing. It's printing 2 here by the white. Why? Why 2? Why not 1?
Because it's line by line.
So it's line by line.
Line by line. You defined the variable as 1 at first, and you said nope, going to define it as 2. So now it just goes back to the most recent occurrence, so it's 2.
Yeah, well said. So on line 1, Jesse equals 1. That's cool. Right now I'm giving 1 the nickname of Jesse. But on line 2, I say, you know what? I'm going to use the nickname Jesse for something else. I'm going to use it for the number 2. So by the time I get to line 3 and we say P Jesse, Jesse's already a nickname for 2. So that's what it prints to the terminal. Is that clear? Any questions about that? Yeah.
So the exercise where we had to keep track of what the green and red were.
Yeah.
Where the red changed, so we had red equals 3 and then red equals 2 plus green.
Yeah.
I think that's what tripped me up when you got that 19. I'm like, where the hell is the 19 coming from?
Yeah.
Because I didn't factor in that you were redefining.
Redefining. Yeah. So that's what we're emphasizing it here, is that you're able to redefine variables.
Yeah.
Yep. So you call it redefining or overriding. That's exactly what's going on. Yep. There are languages where you cannot redefine a variable, but most languages you could. Okay. Now, I spent so much time on these two next examples to introduce this concept. Okay. This is very carefully thought through. Okay. What happens here when I run this code?
You return a value of 2 in the terminal.
So I print 2 in the terminal. Let's see if, is that Shane? Right? So I print 2. Great. Why?
Because we define January as a variable contingent on the predefined value of Jesse plus 1.
Yeah. I know it's January. But yeah, that's fine if it's January. Now, Jesse equals 1, so Jan equals Jesse plus 1. So Jan becomes 2.
Right.
Because as soon as I say Jesse, it's as if I said 1. So this is as if I said Jan is 1 plus 1. So Jan is 2. So when I print Jan, I print 2 to the terminal.
Yeah.
Is this abundantly clear? Okay. Now we're going to put one little monkey wrench in this. What happens here?
Print 2.
Why?
Because it's going to go to the first line of code
Yeah.
that references Jesse.
Yeah.
All right, cool. What's Jesse?
Yeah.
It's 1. All right, so 1 plus 1 for E is equal to new Jesse. Like it's going to use the last variable of Jesse as the meaning.
Does anyone disagree with this? You're right. That's 2. But this is tricky. Why is this tricky? Because when people see a line like this, Jesse equals Jesse plus 1, they're like, what? Yeah, I'm saying Jesse is Jesse plus 1. In algebra, that doesn't make sense, right? Jesse can't be Jesse plus 1, but this is an algebra. To really nail this down, this is what you have to know, the golden rule of setting variables. When you set a variable, everything, so we talked about how the computer processes each line top to bottom, right? That is not the same. That does not hold true from left to right necessarily.
Right.
We go from top to bottom, but we don't necessarily go from left to right like we read English. When we set a variable, the golden rule is that the computer first processes everything to the right of the equal sign first, and then assigns it to the variable name on the left. This is the rule to follow. So when the computer says Jesse equals Jesse plus 1, ignore everything on the left of the equal sign for now, because the order in which the computer processes this is that it first goes to Jesse plus 1 and says, oh, I see you're setting a variable. So I'm going to ignore whatever's on the left-hand side for now. First, I'm going to process whatever is on the right of the equal sign. So the computer says, what's Jesse plus 1? Well, Jesse is 1, and 1 plus 1 is 2. So the computer first figures out that whatever to the right-hand side of the equal sign is, in this case it's 2, and then goes back to assign that to Jesse. And it's overriding Jesse, and it's saying it's true that on line 1 we said Jesse is 1. But now on line 2 we're redefining Jesse, and we're saying Jesse is something else. What is Jesse now? It's whatever is to the right hand of the equal sign. The key here, again, is the order in which the computer processes this. The computer processes the right-hand side first, not like English. So it says, first, Jesse is 1. 1 plus 1, that's 2. And now you say Jesse is 2. Yeah.
Okay, yeah, I was just going to basically say the same thing. So it's saying, oh, hey, 1, it's going line by line. So on line 1 it says 1, we're just going to call that Jesse. Line 2, we're just going to call this previously defined 1 plus 1 Jesse. Then.
Yeah. Again, the key, if you read this from left to right, it doesn't really make sense. Jesse is Jesse plus 1. What does that even mean? So the way to look at it is whenever we're setting a variable, the computer first processes the right-hand side alone in a vacuum. And it says, in a vacuum, Jesse plus 1, which is what it sees on the right-hand side of the equal sign. In a vacuum, that's 2. It says, okay, that's 2. Whatever that result is, namely 2, that is what Jesse now refers to. Jesse is henceforth a nickname for 2. Does this make sense? This is one of the big concepts that trip people up, because it is, again, in algebra that makes no sense. In English it makes no sense. But it's all about understanding the order in which the computer processes that line. Questions? And I have a bunch of exercises where we'll really, if you don't have it clear now, the exercises will make you have it clear. Questions? That took a lot of emotion out of me, because this is a big concept. Okay, before we do an exercise, try another example. Whoops. That's a different Ruby command. Okay, predict what happens here.
32.
Walk me through it.
So, Mary equals 4. Okay. So, that's the first instantiation of Mary. Right,
Yeah.
So now we're going to go to the second thing. Mary equals 4. Well, the original Mary was 4 times 4 equals 16.
So Mary is now 16.
Yep. So now we're just got Mary plus Mary, which is the previous 16 plus 16. So new Mary is 32.
Let's see if he's right. He is right. Does this make sense? Does anyone have any questions about it, even if it makes sense? So Mary's changing. Mary's changing based on the old definitions of Mary. Because the computer first works with the old definitions because it works with the right-hand side first, and then comes back to the left-hand side of the equal sign.
Just a question. So,
yeah.
Just common sense would say, this isn't the kind of thing you would normally use to name that many variables, right? Because that's obviously would confuse the crap out of people. Like,
yeah, this is not...
Like new Mary equals Mary plus 4. Like,
yes, this is very contrived code. This is not realistic by any stretch of the imagination. But yes. If you
did this, you drive someone insane.
Yeah, and your director of engineering might approach you to talk. But it's to emphasize these concepts.
Cool.
Yeah.
Well, I know. I was just wondering. Is there like a common example where you would want this kind of thing?
This is the most ridiculous example on earth,
Okay,
so no. Okay. We've got 2 exercises. Here's the first one coming your way on the general channel on Slack. This is similar to one of the exercises that we had before, in which your goal is to complete the comments on the right-hand side. And if it's helpful, I just moved this terminal. I just shoved it over to the right, because you won't need it, unless you want to check your work. Someone, maybe besides Ethan, help me walk through this exercise. So, on line 3, we have Woodrow, excuse me, which is 10. Hannah does not yet exist. What happens on line 4?
10 minus 5. And you get 5.
So Woodrow is 5. Does anyone know any Woodrows other than Woodrow Wilson? Just curious. I've never met any other Woodrows. Okay. What happens to Woodrow on line 5?
17 plus 5, 22.
What happens on line 6?
Woodrow 45.
Because it's 22 plus 22 plus 1, which I'll take your word for it, it's 45. Oh, we threw in Hannah here. Okay, so Hannah.
So she'll become 42. Because of
Hannah's 42. What about Woodrow? What's Woodrow? Yeah. What happens on line 8? This one I really have to trust in. What was that?
1890.
Does everyone agree with that? Okay. Okay, what happens on line 9?
and become 1890.
Right. And Woodrow stays 1890. Which brings us to line 10. Yeah, line 10 doesn't really change anything, does it? It's completely useless. Yeah. I mean, all this code is terrible. But yeah, that last line is a kicker. Any questions about this? Okay, let me show you something interesting that I unplanned, which is dangerous. I was planning on going straight into the last exercise, but what would, let's try that trick. Boom, boom, yeah, boom. Okay. Let's say I had 2 variables, x is 5, y is 9. And I'm going to try to make this question make sense. Let's say I wanted to swap the variables. So I want x to be whatever y is, and I want y to be whatever x is. Now, obviously I can just go x is 9 and y is 5. Right? But let's say we were writing code and we didn't know what x and y were yet. Let's say, and we'll see examples of this in the future, let's say x and y weren't previously defined in our code, but maybe they came from the user. Maybe the user entered those in somehow. Again, we'll see that example in the future. Let's say I do not know what x and y is. How would I swap them? This is a tricky exercise, huh?
You need a temporary variable in order for that to happen.
Yeah, so let's attempt to do this the wrong way first. If I try to say y equals x and x equals y, let's see if that works or doesn't work. What happens on this line? What's y? Y is now 5, and what's x? So on this line, when I say x equals y, they both stay the same, right? So that is an unsuccessful way to swap them. So Dale's mentioning usage of a third variable, which we can use as follows. So let's make up a third variable called z and say z is x. Okay, so at this point, x is 5, y is 9, and z is also 5. And now we say y is x. So now we say, so x is still 5. What's y?
5.
And what's z?
9. No, 5.
I messed this up. I meant to say x equals y. Let's start over. X is what? 9. What's y? What's z? And what do we say at the end? What's the final line we have to do? Well, before printing it, how do we get, we want to swap them. So x is now what y was, but how do we get y to be what x was? Y equals z. So now, x is still 9, y is 5, and z is 5. Now we don't really care about z. We just use that as what Dale called a temporary variable in order to achieve our result of swapping them. Does that make sense? This is the first example. And then we could print the values at the end if we want to test them out, which we probably should. Yeah, so we successfully swapped them. This is the first example of algorithmic thinking, which is like figuring out how to get a computer to do something which to a human is just so obvious. Right? To us, if you ask me to swap x and y, I don't know, I just swap them. How do you tell a computer that's limited by only understanding like things like variables? How do we get the computer, how do we almost like trick it into swapping variables for us? So we thought of a clever way. This is a clever solution. It's using a third variable to achieve that. The more you work with programming, the more you learn these tricks, and the more they become ingrained in you. But this trick isn't a natural thing. And if I asked you to do this as an exercise, perhaps it would have taken you a long time to figure that out. And that's okay. It's just these are the things, like, once you've seen this once before, you're like, oh, I know the swapping trick, using a third variable. So yeah, this takes a little bit of cleverness. But the more you don't have to worry about being clever as a programmer. It's as you see more and more examples, then you learn how to do these clever things, because you've seen them before. Any questions about this? It's weird, right? Okay. This brings us to the last exercise on variables. This was definitely, by far, the most interesting exercise we'll have done tonight. Let me introduce you to an enemy country called Quizikistan. Now, you may have not heard of Quizikistan, but that's because they're a secret enemy country. And they are the source behind some really intimidating and frightening cyber warfare tactics against the US. And we have located their internal website that controls all of their stuff, all of their evil stuff. And we need to hack it. We need to hack their website in order to stop them from doing all this cyber crime. So I'm going to Slack out to you the secret website of the Quizikistan Central Headquarters website. So I slacked it to just one person, sorry. Slack it on general, it's on general. So this is the Quizikistan Central Headquarters website. if we can take down Kazakhstan, we'll have eliminated a very significant security threat to the U.S. Now, over the course of the 2 weeks, we'll be neutralizing various aspects of the QCH, the Kazakhstan Central Headquarters. But for now, we need to just obtain the first, basically, to get through this website, we need to become certified as an agent where they think we are authorized to use the website. So it's asking us here to enter a passkey, which is another way, that's how you say password in Kazakhstanian. And luckily, although we don't know the passkey, we have hacked the code behind their website, and we were able to pull down one of their files that is the source code that actually fuels this website. And this is true, by the way. This source code, which I'm going to give you, is indeed the real code from this website. And there's more code to it, but this is a real file from this website. This website, by the way, is built in Ruby on Rails, which you may have heard of. So Rails is a web framework where you use Ruby in conjunction with Rails to create websites. So this website is actually built with Ruby. As you can imagine, if I asked you to build a website in Replit, it's like, what? How do I even start? That's what Rails is for. Rails is a lot of pre-written Ruby that other people wrote to basically do the website part for you, and then you write your own Ruby on top of it to customize your website. So this is a real Ruby on Rails website, and here I will slack to you the source code that we hacked from this website. And it's just code. This is the real code behind part of the website, and it is up to you agents to figure out what to do next. Yes, that's very vague instructions. Okay, let's pull up the hacked code. That's not. Okay, so to figure out the first passkey, that's going to be whatever this result is. And that's obviously not intuitive. That's part of the hacking nature of this. Figuring out, oh, whatever that passkey is, that's the first thing I'll need to type in. So a lot of Z's going on here, probably indicating sort of the state of the room at this point at 9:30 at night. What do we walk me through? And honestly, I would just take this, if I need to like keep track of it with comments and stuff, like I would just bring this into Replit so I can actually walk through it. Let's see if it lets me do that. No. Okay, so just working backwards, we could see passkey is whatever ZZZ is, and ZZZ is whatever, I can't even say it, what these are. So, yeah, let's just walk through it. So at this point, ZZZ is 5. Here we got ZZZ is 5, and ZZZZZ, oh man, that's 6? 6 Z's is 10. Here we got ZZZ is 5, ZZZZ, oh man, is 10, and 5 Z's is 15. No pattern to this. Okay, what happens here though? We override, so ZZZ is still 5, but the 6 Z's, and this was the tricky part, whereas it used to be 10 is now 12. And the 5 Z's is 15. So when we add the 5 plus 12 plus 15, we get 32. So if we enter 32, looks like I've done that before. And we submit, we have suspicious activity detected. So you have to enter a second passkey. And that brings us back to, but before I go to that, any questions about this? No? It's clear? Okay. Because you're allowed to have questions. As a teacher, just I like hearing questions. So at some point I'll ask you to humor me. Even if you don't have a question, someone should ask me a question. But we'll save that for a different time. Okay, second check. And obviously you see these def and end. We haven't covered that at all. That's okay. We will cover that, I think, at some point. Okay, Novigrad. I don't know. Sounds Russian. I think it is a city in Russia. You must be planning some attack on Novigrad. So the passkey is going to be whatever Novigrad is. But let's walk through. So it looks like Novigrad keeps on changing here, right? So it starts out as 1,000. What happens next? So Novigrad becomes what? Yeah. And now what happens to Novigrad? Yeah. Doesn't matter the order. Novigrad plus 1 plus Novigrad. That's all the same. And now Novigrad is Novigrad plus Novigrad. So what is it now? Yeah. So now Novigrad is 2004. So hopefully if we enter 2004, and what do you know? It looks like I did that before too. And we submit. We have to go through a third passkey. This is the final hey. And that would be here. Now this one's super annoying. You're probably all muttering under your breath as you're doing this one. So I'm not going to go through this and repl it, but I'm going to sort of just... So Blitzkov starts out 99. As I move my cursor, it's going to be increasing by 1, right? So at this point, Blitzkov is 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120. Is that right? 120? And then we have this unpronounceable variable, which is 2. It's a great nickname for 2. And then passkey is 120 divided by 2, which is 60. So hopefully that's the third passkey. Yes. So you have been assigned an agent name. So actually, it says not to write it down, but you should write it down. You actually all have different agent names, right? Mine is Tyoba. Yours is something else. If you didn't finish this, you finish it later, or steal my agent name. We'll need this for future. We're going to need this agent name to be able to get to other parts of this website as we neutralize other parts of the Kyrgyzstan central headquarters. This, of course, is the Kyrgyzstan national anthem. Yeah, when you get home, you can play it. And listen to it. It's really good. It's really good. Okay. Anyway, has anyone seen that before? People have seen that, right? No? It's one of those like viral things. Okay. Well, good. I'm happy. That's the main takeaway of this course, is that you got to see that video. So check it out at home. Any questions about any of this? No?
Just one quick question.
Yes. Please ask a few quick questions.
So the variables I noticed we had all three of them defined as self.check, and then like say underscore.
Oh, so you're asking about the stuff that is advanced, you mean?
Yeah. So does it matter when we're defining variables, at least in Ruby, if we have periods in the variables, or does it just treat that as...
Yeah, I'm going to decline to answer that question at this time because it's advanced. So, and I don't want to confuse things, but we'll get to that. So, it's a good question. It's actually not even defining a variable in that line. It's defining something called a method, which we'll get to. When designing this course, there's more thought put into what not to say than what to say. I promise you that. I could just like talk about every topic because I like talking, but I put a lot of effort into like what to save for later. So it's a great question. Other questions? Yeah.
So I accidentally discounted I got 121.
Oh yeah, that would do it.
But just to reinforce, even if I did divide by 2, I still get not the remainder. I get the.
Yeah, 121 because, great question. So when we do, I'm just gonna, whoops. So if I do 121 divided by 2, it gives me 60, so you're lucky. When doing math with whole numbers in Ruby, it ignores the remainder when you do division. The only time it doesn't, if you want to get the remainder, use that percent sign. And if you want to really get the real answer, use the decimal point. Although, remember, floating arithmetic might give you some really strange answer that you weren't expecting, but it would be approximately right. Other questions? Okay. If you'll forgive me, we'll stop 7 minutes early because it doesn't make sense to start a whole new topic 7 minutes early. But I'll stay here if people want to ask more questions. Thank you all. And so it's again, the schedule is, if you can imagine doing this, for 3 more nights this week and then 4 nights next week, right? Everyone's aware of that schedule?
Yeah.
Okay. Any questions about logistics? You all got into the building okay? Obviously you're all here, but any issues? Okay, well, it's an easier crowd than I ever imagined.
I was like, that's just.
Yeah.
Are there any places to park around there, maybe where you don't have to pay?
Free parking, I don't know. Is there?
Downtown, like,
Downtown parking.
You're never gonna find it.
Well, there is, you just have to know.
I'm not aware.
Yeah.
It doesn't mean there isn't, but I just don't know where it is. If there is. Yeah. Yeah.
Appreciate it.
Yeah.
Good night, man.
You too, Christine.
All the different separate coordinated.